Hello and welcome to York Universe, the astronomy, astrophysics, and and astrophysics program, I should say, written and presented by students, faculty, alumni, and friends of York University. I'll be one of this hosts your evening, and I'm Dr. Elena Hyde. Tonight, I'm very, very excited to be joined by Zaina Kudur, joining us for the first time as official co-host. We are together broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at about 2 a.m. UT if that's more your speed. The York Universe production works in concert with our online public viewing program run by the amazing Observatory team, which runs at the exact same time. And if you're watching on YouTube live right now, that's where you are, online public viewing. To find out more about OPV, online public viewing, or of course to see all of our wonderful archived episodes, you can always go to yorku.ca/science/observatory, and you can follow the links directly to YouTube or to OPV. If you have any questions or comments or past shows or suggestions for future topics, you can also email us at observe@yorku.ca. Now, we are on social media as well. You can find us on Instagram with the handle York U Observatory and Facebook at LNI Carswell Obs. All of our programs are free, but if you'd like to make a donation or to see some of the very, very cool new observatory swag that we have for sale at the York bookstore, that's that same website, yorku.ca/science/observatory. Now, our online public viewing crew is monitoring the YouTube room for comments and there to take your questions. Right now, the weather is pretty bad. Now, Zaina, it's great to have you on here for your inaugural episode. How are you going on this evening?
Hello, I'm so happy to be here actually.
Great to have you. So, how does it feel to be on the audio end of the broadcast?
It's a different feeling to be, on the other side of the scene, because I've always been, behind the scenes. But yeah, it's a very special feeling, I must say.
Indeed, and of course, I will just shout out Zaina is, in fact, an expert on these broadcasts. She has been a host of the OPV. She has been a co host of many, many things and all over observatory activities. So you might have seen her other places, but this is the first time we've ever been lucky enough to get her on York Universe. Now, of course, tonight we have all kinds of amazing things that we could get planned. If only it was clear outside. Right now, I am seeing nothing but clouds and dark clouds all over. How's the sky look where you are, Zaina?
Oh, pretty much the same, unfortunately. And it's pretty
Cloudy.
cold for June.
Yes, it's downright. It won't stay cold though. I was seeing that within the next 2 days we're looking at some pretty hot temperatures again. But yeah, tonight looks the worst of all worlds, cold and cloudy. Anyways, if it was clear, we would have a lovely crescent moon, just in case your people are wondering. We're on our way to a crescent moon. And if you are curious about what's up in the sky over the next couple days when it starts to get a little bit clearer, we are actually having the shortest lunar month of 2024 at the moment. So the moon is going as fast as it can around Earth at the moment, which is kind of cool. Obviously, you do need it to be not cloudy, or at least not this cloudy, to get a good view of the moon as well. All right, so wishes aside, I will note that our online public viewing crew is over there showing beautiful archive images. So if it's cloudy where you are as well, i.e., anywhere near Toronto, the beautiful archive images of the moon are up, and our crew will be sharing all kinds of wonderful stuff with you guys this evening. Now, tonight we have a whole bunch of stuff planned on our roster. Of course, for Zaina's first episode, we decided to go all out, and by all out, I mean all throughout the solar system and beyond. We have a This Week in Space and Astronomy history, and I suppose I'll go ahead and get us started here. I thought it would be fun to go back in time fair ways, not super far. I'll go back with another one later. But Pioneer 10, the little spacecraft that could, all the way back in 1983 and the 13th of June, so that's plus 3 days, but back in time to 1983, Pioneer 10 was being the first spacecraft to cross the orbit of the planet Neptune. And if you ever had a chance to make a solar system model to scale, you know that Neptune is way far out there. So, this little spacecraft became the first human created object that we know of, anyways, I suppose. But as far as we know, the first human created object to leave the proximity of the major planets of the solar system. So, not near Earth, not near Mars or Venus, way outside. And that was getting across the orbit of Neptune as far as anything had gone at that point. So, 13th of June, 1983. Now, Pioneer 10 really was a little mission that could, because it was part of a big series of exploration events, shall I say. Now, this mission would keep going all the way until 1997. So, just as a little shout out, the 1983 date that I gave you, that's when it was going across the actual orbit of Neptune. Now, Pioneer 10 was actually launched in 1972. So it was launched in March of 1972. It took it until 1983 to get out where no little spacecraft had gone before, and it kept going all the way until 1997. So it was actually almost around abouts of 20 years of activity before the mission came to an official end. And by that time, it had gone well past Neptune, and it had actually gotten to 67 astronomical units, which is a fair distance. So if you've been on the show before, you probably already know. But one astronomical unit is the distance from the Earth to the Sun, and Neptune is at about roundabouts, because its orbit is not totally circular, but a roundabouts of 30 astronomical units, or 30 times farther than um, the Earth from the Sun. This little spacecraft made it out to 67, so twice, more than twice that distance, I should say. Big, big, big distances. That 67 astronomical units is 10 billion kilometers, or 6.2 billion miles. There's nothing on Earth that we can really compare that distance to. So you'll just have to get out your scale models of the solar system to picture it. It was an incredible distance, and of course, it's still an incredible distance today. But at the time, it was the first craft to get out that far. Pioneer 10's weak signal sort of continued to be tracked by what's known as the Deep Space Network, which is a bunch of different telescopes and dishes which are there to help us communicate with our satellites, which is actually an ongoing problem because now we have more satellites to worry about, and of course, more spacecraft in general. But anyways, the Deep Space Network was trying to track and retain the signal from Pioneer 10. And you can imagine at that immense distance, this little tiny craft trying to send its little beep beep signal back. It got so weak that we eventually just could barely track it. So they could barely tell where it was. Basically, they went into theoretical physics to be able to try to untangle the last pieces and get the last bit of signal out of the noise because it was so incredibly weak. And they actually used something called chaos theory, which is from theoretical physics, which I won't bore you all with. But they were trying to extract any kind of coherent data from that extremely weak signal. And if you can imagine it, it's a bit like trying to hear someone whispering in a really noisy room. So imagine you're at a rock concert and somebody, 4 seats down is whispering something. How would you make out that whisper? Well, you'd have to try to somehow extract that little signal from the tremendous noise. And that's what they were trying to do with Pioneer 10. And they basically just kind of got the smallest bits of information to get what's called telemetry, or where this craft might be. And its final, very, 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 very weak signal, the weakest signal that they could possibly get anything from, was received on January 23rd, 2003. And that was when it was 80 AU, so it's 80 times farther than the Earth to the Sun, or 12 billion kilometers, 7.5 billion miles from Earth. So after that, it was just too far away. It was too weak. It could not be heard anymore. The rock concert was too loud to make out that whisper, and that was the last time we really got anything from Pioneer 10. And they did try a couple times after that, just to see could we get anything we could use from Pioneer 10, and the answer was no. A final attempt was made in 2006 in March. And that was the last time that they thought the spacecraft's little antenna for communicating would actually be lined up. So after 2006, they did not get, or in 2006, I guess I should say, they didn't get any kind of signal back. No response was received. And NASA said, you know what? It's not going to happen. We're just not going to be able to talk to Pioneer 10 anymore. It's too far away. And Pioneer 10 actually had a really interesting, I should say, communication array, because this craft, remember, this was put out there in 1972, and they tried to build it with a communications array in 1972. So imagine the electronics and the equipment that they were using at that time. And what they had were radioisotropic thermoelectric generators, or RTGs, and they're what was called SNAP 19 RTGs. And these were for power and communication. And basically, they had what they think happened is that it finally just went below the power threshold needed to actually operate the transmitter. So they thought, you know what, it probably can't even transmit anymore. It's not even getting enough juice to send a signal. So actually, they gave up. And that's a little bit of a sad story, because it's always a bit sad when you have to finally say goodbye. But in 2006, they made the call, look, it's not going to happen. We're not going to hear back from it, and no further attempts at contact have ever been made, as they say. It's out there floating in space, Pioneer 10. And it did have a wonderful, wonderful legacy, of course, as being the first to cross the orbit of Neptune. But not only that, it was part of this whole sort of amazing grand planet tour, or I should say planetary grand tour. um, you probably heard a lot about the Voyager probes, but the Pioneer 10 was right there as well. And of course, Pioneer 10 and Pioneer 11 were the two that went out there, and were, I guess, not quite companions, but colleagues of the Voyager mission. And being early means you get to be the first on several things. And if you look right now, on the NASA website, you can actually still see Pioneer 10's sort of trajectory through the solar system. And so what's happened is it went out, out of Earth, past Jupiter, past Saturn, past Neptune, and it just kept going. And there's actually projects now to even keep tracking where it would go and see where eventually it might land in our galaxy. Because, of course, this craft is going to leave the solar system completely at some point, and go into truly deep space. So of course, Uranus and Neptune are deep space, but it will eventually uh, get even farther. And it does carry the Pioneer plaque, which was made by Carl Sagan. So as it travels out there into the solar system, we can imagine someday somebody might find the Pioneer plaque and know enough mathematics to be able to decipher it. And if you want an extra, even more sort of fun trivia, it was also featured in one of the Star Trek movies. So that's Pioneer 10 this week in space and astronomy history. It's gone all around Neptune, and of course, well, not all around Neptune, but past Neptune and out of the solar system. A really fun mission if ever there was one. Zaina, do you have any fun Neptune missions that you like, or you're what have a different favorite planet?
I think I would like to stick with Mars.
Yeah, I would have to agree because I really like Mars too, but Neptune's pretty cool. I mean, literally, and this was a pretty fun mission.
I agree.
So icy outer solar system is of course really fun, but I won't actually stop you from getting to Mars because I think Mars is amazing, and I cannot wait to hear your next story. So I'll let you go ahead and take it away.
Absolutely. I'm also not gonna go too back in time. About 21 years ago today, June 10th of 2003, it was a special day for Spirit, which was a NASA rover, and Spirit actually had a twin rover called Opportunity, and they were part of NASA's Mars Exploration Rover mission. They were launched about a month apart in 2003, and these rovers were aimed to study rocks and soil on Mars to find evidence of past water activity. Each rover was about the size of a golf cart, but much heavier than the earlier Sojourner rover. The Spirit and Opportunity landed on opposite sides of Mars in areas suspected to have once had water. Spirit launched on, again, June 10th, 2003, so 21 years ago today, from Cape Canaveral in Florida, and landed on Mars on January 3rd of 2004 in Gusev Crater, and I hope I'm saying that right. The landing site was named Columbia Memorial Station to honor the crew of the Space Shuttle Columbia. Spirit's mass-mounted cameras provided 360-degree views of the Martian terrain, and it used various instruments to study the soil and rocks, including a rock abrasion tool to grind surfaces. Initially, Spirit sent data via the Mars Global Surveyor and then switched to the Mars Odyssey. And in January of 2004, Spirit faced a major problem with its flash memory, but it resumed normal operations in February. Spirit made history by grinding a rock surface on Mars for the first time. The mission was extended well beyond the planned 90 days, with Spirit visiting Bonneville Crater and Columbia Heights and investigating many interesting sites. Spirit's discoveries included uncovering pure silica, which indicated past water activity, and finding evidence of an ancient explosion at a location called the Home Plate. The rover also captured movies of dust devils, providing insights into Martian wind patterns. And in May of 2009, Spirit became stuck in soft soil, and by November, it had lost a wheel. The mission was reformulated as a stationary science platform to study Mars's rotation. So I guess that's the creativity of scientists to reformulate missions. And after losing contact in March of 2010, and despite numerous attempts to re-establish it, NASA ended the mission on May 25th of 2011, marking Spirit's journey, which extended about 4.8 miles. And it had operated for over 6 years, which is 25 times more than its original intended lifetime. and its discoveries provided significant evidence of Mars's wetter past and greatly enhanced our understanding of the planet. So, yeah, I guess my story ended on a similar note.
Yeah, well, we really like to get as much as we possibly can out of our spacecraft, I think is the commonality here. Of course, with the Voyager 10, they kept trying to, or I mean Pioneer 10, find any chance of keeping in contact with it. And of course, with Spirit, it's exactly the same. They really wanted to try to keep in contact with it because it is quite difficult to get these little crafts out there. And Spirit, of course, was not so little. Spirit and Opportunity, as a reminder, I mean, they're not as large as things like Curiosity, but they were a lot larger than some of the other crafts that have gone out there. They're actually around the size of golf carts. So they're not super, super tiny. And those two rovers, Spirit landing in Gustav Crater and Opportunity landing pretty much in the other side of Meridiani. Sorry, I always say this wrong. Meridiani, I think, Planum, and being able to have contrasting regions with different areas. It's just such a wonderful mission. Of course, you'd want to stay in contact with it. And you mentioned, of course, grinding a rock. Spirit also has some really great photos of when its wheels weren't completely stuck, but they were dragging, and it actually dragged its wheel over a bunch of different soil types and churned up different colors of soil that were underneath the surface, which actually told us all kinds of things about what that might be. And the area of it's basically like those skid marks you get from peeling out your car. That's what they did with Spirit on the surface. They kind of like drug out the wheel, and what they found in that different colors of Martian surface is very similar to what you'd find on Earth in hot springs. And usually on Earth, where you find hot springs, you do tend to find, certain bacteria and microbes. So if it's true that there used to be hot springs on Mars, then Spirit would have been one of the first to drive over them, or I suppose they're remnants. But yeah, wonderful mission, and of course we'd want to keep in touch with it if we possibly can. Um, all right, let's see here. Okay, so Mars is awesome. Um,
I
um,
agree.
and we'll go ahead and probably be coming back to Mars a lot more if we possibly can. I will just say, focusing on Spirit, don't forget that it was also, I believe it was mostly Opportunity, did find the Martian blueberries, or I should say, the Martian iron-rich spherules, which were nicknamed blueberries, and those have some wonderful, wonderful pictures online. So I can very much recommend both of those missions. Yeah, Mars. Okay, we should move on. Otherwise, I'll just keep talking about Mars. So I want to go back in time a little more and do something a little extra historical. So sending spacecraft is all great, but what about some good old-fashioned calculations? So I'm going to go back to 1846, and I'm cheating just a little bit because it's June 1st and not the 10th. But it relates to Neptune actually. So I suppose I'm keeping us cold here and going back to Neptune. A little bit colder than Mars, or a lot a bit colder than Mars. But yeah, Neptune we did not always know about. Neptune was a planet that was discovered via calculations. And on the June 1st in 1846, so this is getting to be a while ago now. So 1846, there was quite the hunt going on for what could possibly be the thing that is perturbing Uranus's orbit. Now, William Herschel, serendipitously or accidentally, depending on who you ask, discovered the planet Uranus in March 1781, and he wanted to call it Georgium Siderum or George's Planet. And it actually was called George's Planet through the 1800s, I believe. But that's another story. But after he discovered Uranus, the orbit wasn't following what mathematicians said it should. So in 1781, they did actually have enough knowledge about the orbit of planets and Newton's law of gravity to predict what the path should be. And they knew it wasn't there. So what could be perturbing it? There must be something else beyond Uranus. And a major planet hunt started up all over the world. Everybody wanted to try to make those predictions, to do those calculations. And it was June 1st, 1846, where one particular scientist, Leverrier, a French scientist, announced his results for the search of what would then become known later as the planet Neptune. So finding Neptune was extremely not easy. It was very unstraightforward, roundabout, curlicue. People were trying all kinds of things. There was international intrigue, missed opportunities, lots of different people involved in different countries all over the world. And in the end, Neptune's actual discovery actually hinged on a little bit of luck that went almost unnoticed for 150 years because people had been, of course, watching the skies. And it's easy to forget that, in most of the 18th century, aside from the politics and the discovery of gravity and Kepler and, everything that was massively going on. The solar system, however, was not so incredibly complex. We had the sun, and once we could accept that, heliocentric solar system was okay, there were 7 planets that we could find. We had our Earth and our moon going around us. We had, of course, Mercury and Venus, and we had Jupiter, and Jupiter had 4 moons that we could see. Not to, not counting the extra 50 odd that we know now today. And Saturn, of course, just had 5 moons, not counting the extra odd 50, 60 we know today. So it was very simple: 7 planets, a few moons, 1 for Earth, 4 for Jupiter, 5 for Saturn, a couple comets. And, right at that point, in 1846, I don't think they had actually even filled in the asteroid belt. So the zone between Mars and Jupiter, they did not know that there was an asteroid belt there. It's actually pretty hard to see. It's very dispersed and not dense. So they're like, no, nothing there, just a couple planets, a couple moons. And after Saturn, beyond Saturn was just nothing. There was nothing beyond Saturn. That's crazy. We can't see it. There must be nothing out there. However, that's about when William Herschel started using his telescope and getting out there, and eventually he noticed something odd going on with a star, and that turned out to be the planet Uranus, and that was March of 1781. And once that happened, the scientific community of Europe in particular really started changing big time because, as I say, William Herschel, he originally didn't even want to call it Uranus. He wanted to call it Georgium Siderum, after his patron, because you needed a patron to pay you if you were going to do science. Um, and uh, and yeah, they thought, well, there might be more out there. Uranus, in particular, refused to follow the path mathematicians insisted it should. So something is causing this planet to not have the motion that we know it should because we believe in the laws of physics and every other planet follows them. I mean, this is before Mercury's orbit, anyways. But they knew that something could be out there, and they thought, let's have a search. Let's have an actual proper search where we go out and investigate the the solar system. So they did. And a lot of people got very, very interested. So there's some sort of mystery beyond the orbit of Uranus in 1821. So this is 1821, before the 20 years before Leverrier-ish. French astronomer Alexis Bouvard published tables of Uranus's motion. So tables, well calculated tables. And this is actually a fun other story we'll have to talk about some other time. But Bouvard was a shepherd, not an academic at all, who actually rose to become the director of the Paris Observatory. And he was attempting to combine pre-discovery observations of Uranus from star catalogs that have been taken all the way back to 1690, so hundreds of years. And with the more accurate observations made since Herschel discovered Uranus, because of course this was also during the telescope boom, the technology boom, the first real optics, amazing stuff. And yeah, Bouvard could not do it. He actually found that he could not reconcile the orbit of Uranus with the previous observing. And he discarded the older observations. He actually just threw them out. And for just a moment, Uranus's motion seemed to be reconciled with theory once he discarded all the older observing. But it soon became off again. And so before 1821, Uranus appeared to be moving faster than it should have been. So gravity doing something. And this is based on the known bodies near it. So at that time, Saturn, Jupiter, and nothing else. But then a few years later, it appeared to be moving too slowly. So Bouvard actually himself suspected, and this is 20 years before Leverrier, he actually suspected an unknown planet might be the cause, but he did not follow up and he did not publish, and so he did not get the credit and he did not figure it out. So over the years, the difficulty of explaining the future path of Uranus got worse and worse and worse. And a lot of people started investigating, but in particular, John Couch Adams, a native of Cornwall, and the other, our astronomer, I should suppose, the astronomer of this story, Leverrier, or Jean-Joseph Leverrier of France. He was a private tutor and assistant teacher at École Polytechnique, and he actually devoted his time to researching celestial mechanics. And if you want to see some really terrifying math, have a look at the stacks and stacks of calculations that Leverrier did. And it is an amazing challenge that both Adams and Leverrier set for themselves, um, to make these predictions and to try to figure out exactly what was causing the perturbation in Uranus's orbit, what it was and where it was, and then go observe it and get proof. So he obviously, we're in a bit of a competition for the best calculations, and Leverrier was known as a calculating machine. So this is somebody who was, and by the naming of his peers, incredibly good at math. So one of the students from Paris Observatory at the time wrote of Leverrier, and this is a quote: "He double checked every calculation and did a lot of them mentally," and that is no small feat at all. This is very hard math, and he was doing a lot of it in his head, and his work has been checked with and found to have almost no errors at all. So Leverrier announced his results and included a position for the proposed disruptor of Uranus, i.e., planet. And at that time, another sort of famous figure comes into play. Airy from the name Airy Disk comes from, actually. So this is what was his name? I forget his first name, so you'll have to forgive me on that. But he actually saw Leverrier's calculations and convinced a observatory to try to find that region of sky at Cambridge University Observatory. And was an 11.6-inch refracting telescope, so super long glass lens, state of the art at the time. Yeah, basically, he actually got in and recorded Neptune twice in August. Chalice, who was doing these first observing sessions, he got two observations, but he didn't do the comparison between positions. And because he didn't do that, he didn't actually get credit for the discovery. And so it actually ended up being several years later. So this was June 1846. He announces the results, Leverrier does, and then it gets follow up, but then they don't do the position comparison. And then it was in September, so a few months later, there's another observatory checking in Berlin. And this is a student actually gets very motivated, Heinrich Louis Darest, and he actually got in and did the observing and found the planet. so, so Neptune is an amazing find, international furor, I suppose, or um, outrage, upheaval, chaos. What came out when it was actually discovered, the actual observing follow up and full discovery was very dynamic, and the French and the British were not particularly good friends at this time. So it was, nationalistic rivalry at that point because Leverrier had done it correctly. But then, of course, the observing took longer than it should, and finally there was, after much upheaval, an international consensus that both Leverrier and Adams would actually share credit, having done similar calculations around the same time, and then a whole bunch of people who had observed would be there. And Leverrier was the one who proposed the name Neptune for the planet. Um, and Leverrier actually, and this is a little bit of intrigue right at the end, he said it's going to be called Neptune, and this has already been approved by the French Bureau de Longitude. And, you know, uh, Basically, it got named Neptune even though it actually wasn't approved. And he tried to sneak in calling the planet after himself, somewhere in the middle there. So Neptune and history has an amazing time, and I think it's one thing to realize that these planets are incredibly far out there in our solar system, but it's also really incredible how some of these discoveries came about.
That is wonderful indeed. You know, it always amazes me how committed scientists and like at those times were compared to us. We have the luxury of code and simulations and supercomputers. So I have a completely different appreciation now that
Yeah.
I have, advanced in my studies.
Well, it is fair to note though that back in 1846 you would not have had to take the E&M classes or the thermodynamics classes. So, it would have been some things would have been easier. But yes, the do-it-yourselfness of the astronomy at the time, you really could just go out there with a big notebook and do the calculations if you so wanted to, if your brain was willing to do the math, and it's a lot of math. And of course, finding Neptune was the first time we as humans that we know of had ever found a planet purely by predicting for it. And that was quite the thing. Now, of course, Mars, we didn't have to do that because Mars is visible to the naked eye, so we can see it move in the sky. And Mars has an equally storied history, I would say, but a little bit its retrograde motion is probably the one I think would be the closest parallel to the Neptune story. Now let's see. We'll go and talk about Mars in a minute, but I think actually we're about halfway through. So I'm going to go ahead and do the reminders here before I forget, or we'll leave the halfway point. All right, everyone, this is a reminder that you are in fact listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can find us at yorku.ca/science/observatory. And of course, you can join us on Instagram or on Facebook, Yorku Observatory or Allan I. Carswell OBS. Tonight, you're listening to Dr. Elena Hyde and Zaina Kador, who is joining us for her very first episode. So say hooray, everyone! We are discussing Mars and Neptune and all kinds of great things. So we'll go ahead and without any further ado, I will just lead us straight back over to Mars. And Zaina, I think in addition to Mars missions, actually I'm a little bit wrong. We're gonna skip over Mars and talk about something a little bit different. Is this also in icy outer space or
This
near
is
Earth?
more of an asteroid mission, actually.
Oh, right, you're gonna return us back to Earth, aren't you?
A little bit.
Oh my gosh, I can't wait. All right, let's go.
All right, so on June 13th of 2010, the Hayabusa mission was launched, and that was the first sample return mission by the Japanese Aerospace Exploration Agency, or JAXA for short. And its goal was to rendezvous with asteroid Itokawa and collect samples to return them to Earth. So it was launched actually on May 9th, 2003. I must say that June 13th, 2010 was an important day for that mission, and we will find out why. But the launch date happened actually on May 9th of 2003 from the Uchinora Space Center. And the Hayabusa mission reached the Itokawa asteroid in November of 2005. The spacecraft made several attempts to collect samples using touch-and-go maneuvers. And during one attempt, it lost communication with Earth and crash-landed on the asteroid. And as a result, the spacecraft was damaged. But despite this setback, JAXA was able to successfully return Hayabusa to Earth on June 13th of 2010. So I guess we did get something special out of the mission after all. And although the sampling mechanism did not work quite as planned, thousands of tiny particles, about 10 to 100 micrometers in size, were found in one of the sample containers. And these particles were likely introduced during the spacecraft's impact with Itokawa's surface, so the asteroid's surface. And many of these particles were identified as asteroidal grains based on their chemistry and mineralogy, though they were mixed with contaminants from the spacecraft, of course. And instead of returning several grams of sample, the Hayabusa mission brought back less than a milligram. However, these are the first direct samples from an asteroid, and their geological context is well documented thanks to the extensive surveys conducted by Hayabusa. Therefore, they hold a great scientific value despite the crash that occurred. And the initial chemical and mineralogical analysis was carried out by the Hayabusa Joint Science Team, which included scientists from Japan, Australia, and the United States. NASA having supported the mission, received about 10% of the returned samples. And the first 15 Hayabusa particles were delivered in December of 2011 and are curated at Johnson Space Center. These samples are available to the international community, or actually were available to the international community starting in early 2012. And scientists could request Hayabusa samples from the curator at JSC, that is the Johnson Space Center, following the guidelines and deadlines listed in the sample requests section on the JAXA website. That is for anyone who's interested in requesting some asteroidal samples.
Well, I keep that in mind that you will have some pretty stiff competition, so I wouldn't underestimate the amount of demand. That said, it was, of course, this was an amazing, really boost for sample return, and now we've seen it working now several times. It just gets better and better every time we do a successful sample return. Of course, now recently we also had, of course, the sample return by OSIRIS-REx from Bennu, which is the kind of like almost diamond-shaped asteroid, and that one came back, pretty. Was it last year? 2023? Yeah. This is still 2024, right? Yeah. So
Yes, it
yeah,
is.
yeah, it was just last year. So we're seeing more and more of these, and I have to say I just love it. All right, so before we get too far afield or come back, no, as long as we're back on Earth, I think I'll just go ahead and skip into a couple reminders so we can get to some news items because we have some really fun news items for today. And I'll just give a little extra shout out as a last this week in space and astronomy fun fact. Speaking, since we had a sort of Neptune and icy outer solar system and Pioneer 10, just in case anybody was wondering, back in 2008, on the 11th of June, this is when the International Astronomical Union, or IAU, finally walked back a little bit of their, I suppose, anti-Pluto-ness, where of course, they had stripped Pluto of its classification as a planet after the debate in 2006. Very controversial, but it was in 2008 that they actually decided that Pluto could be the leader of a new class of objects that would be called Plutoids, and that was 11th of June. So, on our way to the news items, well, just one quick reminder as well. If you are interested in following along with the Astronomer in Residence program out at Killarney Provincial Park, we do have some astronomers heading out there, and so the blog has actually started back up on yorku.ca/science/observatory. You can just go to Astronomer in Residence. And the other note is that this week, on the 12th of June, we do have an atrium tour on the Wednesday. So our Wednesday night tour will be on top of the Arboretum parking garage and not in the Petrie building. So if you are coming in person, just be aware of that and please make sure to go to the correct building. You won't need any keys or anything to get to the top of the parking garage. You can just go to any corner and take the lift up to number 5 or the top level, which is open air. All right, so let's get to some fun news items. There's so much going on right now in science, as always. I really love the story that you found for the Gaia Space Telescope, Zaina. I think it's a really fun one. Shall we start there?
Yes, let's get going.
Absolutely.
So, new
Hooray!
findings from Gaia. As always, I feel like this is not really news because there are always new findings from Gaia, but
Yes.
trust me on this one, it's new. These are some new insights on cosmic collisions. So, new findings from the Gaia Space Telescope suggests that the Milky Way may have cannibalized a small galaxy relatively recently, in cosmic terms, of course. Previously, astronomers believed that the last major collision occurred much earlier. However, Gaia's precise tracking of over 100,000 nearby stars reveals wrinkles, quote unquote, in the Milky Way that point to a significant galactic merger about 2.7 billion years ago. That is far later than we previously thought. And these wrinkles, which were discovered in 2018, result from smaller galaxies being torn apart and their stars spread across the Milky Way. The recent research, led by Thomas Donlan from the Rensselaer Polytechnic Institute, indicates that the last major merger involved a dwarf galaxy, which was dubbed the Virgo radial merger, contradicting the earlier belief that the Gaia Sausage Enceladus merger was the last significant event. Professor Donlan also explains that by comparing the wrinkles in Gaia's data with simulations of galactic collisions, we could trace back the timing of these events. The Virgo radial merger brought new stars and possibly other dwarf galaxies into the Milky Way, reshaping our understanding of its history. And Heidi Joan Newberg, also from the Rensselaer Center or Institute, noted that the clarity of these stellar wrinkles suggests that they must have formed within the last 3 billion years, which is much more recently than the previously estimated 8 billion years. This groundbreaking research was published in the monthly notices of the Royal Astronomical Society, and it continues to evolve our understanding of the Milky Way's dynamic history, showcasing Gaia's unparalleled ability to map and explore our galaxy. How wonderful is Gaia?
It is pretty wonderful. It's as I say, it was and is and shall remain to be one of my favorite missions. It absolutely is doing as advertised. And it's not just, of course, looking into the Milky Way galaxy, it's doing all kinds of interesting stellar studies, astrometry, positions, distances, which is huge, parallaxes, and of course exoplanets. So you can't discount the exoplanets, and it does target objects that are a little bit on the bright side, so brighter than magnitude 20, which means, of course, that our own telescope, the 1 meter telescope at the Allan Carswell Observatory, is in a unique position to actually be able to also observe Gaia objects for follow up if needed, which I just thought was super, super fun. And, galactic archaeology and being able to determine what's going on in our local group or in our Milky Way helps us when we go out to see things at the very, very distant edges of the universe in JWST data, for example. And they've seen things like extra structures in the Milky Way. They've seen things like warps in the spiral arms of the Milky Way. And the more we're finding about it is that our galaxy is actually an incredibly complicated structure. And one of the first predictions of galactic archaeology is that when you form a galaxy or you try to form a galaxy, there would be lots and lots and lots of debris. Like there would be lots of remnants, as you mentioned, Zaina, these kinds of remnant structures, and pieces of other star clusters and satellite galaxies, and there would just be stuff all over. And for the longest time, we couldn't really see it because a lot of those structures are too faint and they're very hard to untangle from the rest of the Milky Way. But what Gaia is doing is really helping us to untangle a lot of that. Um, and looking for things like stellar siblings, stars that have formed together in the same cluster and then have spread out throughout the Milky Way. Really, really interesting stuff. So yeah, totally recommend Gaia Data just in general, and this is a really fun one. So thank you for bringing that. Thank you for bringing that one in. Now we have a few more minutes left, and since your article, I think, is probably better than mine, I thought this is actually a natural lead-in to the JWST science that you found, because of course, JWST does something very, very different. Shall we skip down to JWST, or do you want to try to do black holes first?
Absolutely. Let's do JWST. That is like a benchmark of our news items every OPV.
Yes.
So would love to keep that in. So, as we all know, NASA's James Webb Space Telescope is revealing unprecedented details about supernovae from when the universe was much younger. Using Webb data, a team has discovered 10 times more early universe supernovae than previously known, including some of the most distant examples used to measure the universe's expansion. And Krista DeCursey, a graduate student at the University of Arizona, said, begin quote, Webb is a supernova discovery machine, end quote. The JWST Advanced Deep Extragalactic Survey, or JADES, helped identify supernovae with light stretched due to cosmological redshifts that were previously unknown, or probably undiscovered or unexplored. And in the near past, only a few supernovae were found above a redshift of 2, corresponding to when the universe was 3.3 billion years old. JADES, which was the JWST Advanced Deep Extragalactic Survey, also revealed supernovae from when the universe was under 2 billion years old. The team compared images taken up to a year apart and identified around 80 supernovae in a tiny patch of sky that was the size of a grain of rice. Justin Burrell from the Space Telescope Science Institute emphasized this first significant sample of high redshift supernovae, helping scientists determine if these distant explosions differ from nearby ones. And the team found a high redshift core collapse supernova at 3.6 redshift, which was dating back to when the universe was 1.8 billion years old. And notably, they discovered a type Ia supernova at a redshift of 2.9, breaking previous records and tracing back to when the universe was 2.3 billion years old. Burrell's analysis suggests no significant variation in intrinsic brightness with redshift, and that is supporting the current theories about the universe's expansion. So yeah, also amazing, amazing discoveries and achievements coming in every day from JWST.
Yes, and this is another one that I definitely recommend people to go look up, and especially for the JWST images, see if you can actually get the images off of this because the deep field observations taken by JWST are a real treat. It really goes to show, as you say, this a lot of these fields are zoomed in on a very, very small patch of sky. And one of the fun things in astronomy is people ask, well, if the galaxy is filled with stars and the universe is filled with galaxies, why is the sky dark at night? And that's the Olber's paradox. Well, a lot of that light hasn't had time to reach us yet. But also, if you look far enough in any direction in the sky, you look back in time and you find that every tiny little piece of black you see in the sky is actually full of galaxies. So the sky isn't so much dark at night as it is completely filled with incredibly dim galaxies, which I just think is so, so fun. And the Jade's deep field observing is a wonderful, wonderful example of that. A lot of people have heard of the Hubble Deep Field. This is a similar idea, and of course, James Webb Space Telescope has different wavelength ranges to take into account. But looking at stars that are exploding at these distances, a lot of times we are looking at really is just a galaxy where a supernova has exploded, and as a result of that, the whole galaxy has changed in brightness. So it's going back to the early universe, going back to early galaxies, and talk about galactic archaeology. This is the other end of that, actually viewing the most distant objects in the universe that we can possibly see. So really, really fun stuff. All right, so we're gonna have to leave a couple of our stories on the cutting room floor for next week or next time Zaina comes back on the show, and we'll probably wrap up here tonight. Any favorite stories from this evening, Zaina?
I have to admit, I think the Gaia story is my favorite so far.
Well, I am happy to agree with you. All right, everyone. Thanks for joining us this evening. You have been listening to York Universe, and of course, the first official episode with co host Zaina Kodur. This York Universe is an astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been Zaina Kodur and myself, Dr. Elena Hyde. You can always connect with us on Instagram and Facebook at Yorkview Observatory or Allan Carswell Obs, respectively, and check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in to York Universe, everyone. Clear skies and have a good night.
Good night.